Welcome to mathematics class, matrices part 13. So today we are going to discuss one of the important concepts in this chapter, solving system of simultaneous equations by using matrix methods. In the last class, we have discussed about Cramer's rule, how to solve the system of equations by using Cramer's rule. In last class we did. Today we are going to learn the second matrix method to solve simultaneous equations. Solving system of equations by using matrix inversion method. మాత్రిక విలోమ పద్ధతిలో సమీకరణ వ్యవస్థను సాధించడం ఇప్పుడు మనం నేర్చుకుందాం. So for a given system of simultaneous equations, we have to convert it into matrix equation. We learned in the previous class. Ax is equal to D is the matrix equation for the given system of simultaneous equations. Ax is equal to D అనేది ఇచ్చినటువంటి సమీకరణ వ్యవస్థకు మాత్రిక సమీకరణం. ఇక్కడ A గుణక మాత్రిక, X చలరాశి మాత్రిక, D స్థిర రాశి మాత్రిక. A is the coefficient matrix, X the variable matrix, D the constant matrix. From this matrix equation, if you multiply both sides by the inverse of A, that is A inverse. So taking A inverse both sides, and A inverse A will be the unit matrix I. So I into X is X. So we get X is equal to A inverse D. X is equal to A inverse D. Once again, look at this. Ax is equal to D is the matrix equation. For this matrix equation, multiplying both sides with A inverse, left side and right side. What happens left side? A inverse A, if you write together, A inverse A or A into A inverse will be the unit matrix I. A inverse A గాని A into A inverse అయినప్పటికీ అది యూనిట్ మ్యాట్రిక్స్ అవుతుంది. I identity matrix. So identity matrix into any matrix is itself. I into A అవుతుంది, I into B అవుతుంది, I into X అవుతుంది. So we get X is equal to A inverse D. What is X? Is the variable matrix. So the variable matrix XYZ is the required solution. So the solution for this system of equations is X. That will be A inverse into D. The product of A inverse and D, the constant matrix, will give the solution for this system of simultaneous equations. ఇచ్చిన సమీకరణ వ్యవస్థకు సాధన A ఇన్వర్స్ D యొక్క లబ్ధం అవుతుంది. విలోమ మాత్రిక, స్థిర మాత్రిక యొక్క లబ్ధమే మనకు సాధన సమితి అవుతుంది. సో ఇక్కడ A ఇన్వర్స్ ఉంది కాబట్టి ఈ మెథడ్ను ఇన్వర్స్ మెథడ్ అని కూడా పిలుస్తాం. సో హియర్ A ఇన్వర్స్ is involved So this method is called inversion method or matrix inversion method, or simply inverse of a matrix, A inverse. By using inverse of a matrix, how to solve the given system of equations. Okay. X is equal to A inverse D. So in this method, we calculate first inverse of A, and then the product A inverse into D will give us the solution. We know how to calculate, how to find inverse. So adjoint by det A. So for this, we need to calculate adjoint matrix and then determinant of A, and then the product A inverse into D, that will give us the solution. ముందు A inverse కనుక్కోవాలి. A inverse కనుక్కోవాలంటే adjoint det కనుక్కోవాలి. adjoint by det అనేది A inverse అవుతుంది. ఆ తర్వాత దాన్ని D తో మల్టిప్లై చేస్తే మనకు సొల్యూషన్ వస్తుంది. సో ఫర్ దిస్ this is the procedure to find solutions of given simultaneous equation. So now let us take up some problems from the exercise. From the exercise 3H in the textbook. Solve the following system of equations. Solve the following system of equations by using matrix inversion method. By using matrix inversion method. మాత్రిక విలోమ పద్ధతిలో వీటికి సాధన కనుక్కోవాలి. ఇందులో let us take up second problem. Already we did it in Cramer's rule. So whatever the method it may be, solution will be same. So the equation x plus y plus z is equal to 1. The first equation, x plus y plus z is equal to 1. 2x plus 2y plus 3z, 2x plus 3y plus 2x plus 2y, 2x plus 2y plus 3z is equal to 6. X plus 4y plus 9z is equal to 3. So as usual, as in the case of Cramer's rule, the first step will be same. First, convert the equations into matrix equation. So first coefficients of x, y, z in first equation, second equation, third equation. 1, 1, 1. x, y, z గుణకాలు 1, 2, 3 సమీకరణాలలో సెకండ్ ఈక్వేషన్స్ లో x, y, z కోఎఫిషియెంట్స్ 2, 2, 3. And third equation coefficients 1, 4, 9. 1, 4, 9. So ఇది first coefficient matrix. X, Y, Z variable matrix and constant matrix 1, 6, 3 is constant matrix. So here let us name it as A, first matrix, second matrix as X, and third matrix as D. So this is called AX is equal to D is called matrix equation. This is called matrix equation. Here A is a coefficient matrix, X variable, D constant matrix. So taking A, we have to calculate, we have to find A inverse. So what is A inverse? Adjoint A by det A. So first we need to find adjoint of A. A యొక్క అనుబంధ మాత్రిక కనుక్కోవాలి. అనుబంధ మాత్రిక కనుక్కోవాలంటే కోఫాక్టర్ మ్యాట్రిక్స్ కనుక్కోవాలి. దాని ట్రాన్స్పోజే అనుబంధ మాత్రిక అవుతుంది. First calculate the cofactor matrix, and the transpose of cofactor matrix is adjoint matrix. So to find adjoint of A, first we need to find cofactor matrix. Now let us find cofactors. Already we learnt how to find adjoint matrix and inverse. Cofactors. Cofactors of matrix A. Now, in R1, in first 3 elements are there, R2 3 elements, R3 3 elements. So in R1, cofactor of first one, let us name it as cofactor of 1, take it as A1, capital A1. So 1 for 1 ఉన్నటువంటి అడ్డు వరుస 1 ఉన్నటువంటి నిలువు వరుసను మినహాయించి మిగతా 4 మూలకాలతో ఏర్పడే మ్యాట్రిక్స్ డిటర్మినెంట్ తీసుకోవాలి. సో 2, 3, 4, 9. 2, 3, 4, 9. So excluding the row and column in which the element lies, and take the remaining 4 elements. 1 ఉన్న రో 1 ఉన్నటువంటి కాలమ్ను ఎక్స్క్లూడ్ చేసి, except the row and column in which the element lies, that take the remaining 4 numbers. And calculating this determinant, 2 9 ja 18, 4 3 ja 12. So 18 minus 12, 6. The cofactor of first row, first element is 6. Similarly, in first row, the cofactor of the second element, let us name it as B1. So for this, we need to multiply. So this one, cofactors of these 4 numbers will be negative. We'll change the sign. Already we discussed why the sign changes. -1, we need to multiply with -1 to the power I plus j. I the number of the row, j the number of the column. So for this, it will get minus sign. So for B1, the second, we need to multiply with minus. So excluding the row and column, 1 and 1 to 4 column, the remaining 2, 3, 1, 9. The remaining 2, 3, 1, 9. So minus of 2 into 9, 2 9s are 18, 3 1s are 3, 18 minus 3, minus of 15, minus 15. And similarly, the cofactor of first row, third element, cofactor of first row, last third one, that is also 1. Let us name it as C1. So excluding the row and column in which the element lies. So first row, leave the first row and third column. Take the remaining 4 elements, 2, 2, 1, 4. 2, 2, 1, 4. ఎలిమెంట్ ఉన్నటువంటి రో కాలం వదిలిపెట్టి మిగతా 4 మూలకాలు తీసుకోవాలి. సో ఇక్కడ డిటర్మినెంట్ 2 4 జా 8, 2 1 జా 2, 8 minus 2, 6. 8 minus 2, 6. ఇది R1 అయిపోయింది. నెక్స్ట్ in R2, in R2, cofactor of R2 first element 2. So let us name it as A2. So for this, we need to multiply with minus and excluding the row and column, the second row and first column, the remaining 4, 1 1 4 9, 1 1 4 9. ఈ ఎలిమెంట్ ఉన్నటువంటి రో, సెకండ్ రో అండ్ ఫస్ట్ కాలం వదిలిపెడితే, లుక్ ఎట్ దిస్, 2 అనేది సెకండ్ రోలో ఉంది, సెకండ్ రో కంప్లీట్ గా వదిలిపెట్టాలి. 2 అనేది ఫస్ట్ కాలంలో ఉంది, ఫస్ట్ కాలం సెకండ్ రో ఇది ఎలిమినేట్ చేస్తే 1 1 4 9 ఎలిమెంట్స్ మిగులుతాయి, అవి తీసుకోవాలి. అండ్ డిటర్మినెంట్ 1 into 9, 9, 4 into 1, 4. So minus of 9 minus 4, 5, minus 5 అవుతుంది. సిమిలర్లీ సెకండ్ రోలో సెకండ్ ఎలిమెంట్ కోఫాక్టర్ ఆఫ్, ఇది కూడా 2 ఉంది, లెట్ us name it as B2. సో ఇది మిడిల్ ఎలిమెంట్. సో సెకండ్ రో సెకండ్ కాలం వదిలిపెడితే కార్నర్ 4 ఎలిమెంట్స్ వస్తాయి, 1 1 1 9, 1 1 1 9. డోంట్ గెట్ కన్ఫ్యూజ్. దేని కోఫాక్టర్ కావాలంటే ఇప్పుడు ఈ మిడిల్ ఎలిమెంట్ సెకండ్ రోలో సెకండ్ ఎలిమెంట్. సో ఈ సెకండ్ రో అంతా వదిలిపెట్టాలి, సెకండ్ కాలం వదిలిపెట్టాలి. ఇవి వదిలిపెడితే మనకు ఈ కార్నర్ లో ఉన్న 4 ఎలిమెంట్స్ మిగులుతాయి. 1 1 1 9. సో 1 1 1 9 తీసుకొని దాని డిటర్మినెంట్ 1 into 9 9, 1 into 1 1, 9 minus 1 8. So next, cofactor of the second row third element, that is 3. Let us name it as C2. So for this also we need to multiply with minus. Don't forget 4 numbers cofactors will be negative, and the row and column in which the element lies, second row third column. If you remove second row third column, 1 1 1 4 will get 1 1 1 4. Look at the matrix. For 3 is in second row, so leave second row. 3 is in third column, so leave third column. Second row third column, if you remove second row and third column, the elements left over 1 1 1 4. So we take 1 1 1 4 and then calculate the determinant. So minus of 1 into 4 AD minus BC, 1 into 1. So minus of 4 minus 1 3. So that is minus 3. The second row cofactors also over. Now let us calculate cofactors of third row in R3. So cofactor of third row first element, that is 1. Let us name it as A3. So for this, the third row and first column, 1 lies in third row and first column. First column third row వదిలిపెడితే 1 1 2 3 మిగులుతాయి. 1 1 2 3. Look at this, the third row first element. So it is in third row, so third row remove, and first column third row remove చేస్తే the remaining elements 1 1 2 3, 1 1 2 3. So calculating 1 into 3 minus 1 into 2, 3 minus 2 is 1. The cofactor of third row first element is 1. Similarly, cofactor of third row second element, that is 4. Let us name it as B3. For this we need to multiply with minus. So this 4 lies in third row, so leave third row and second column. Third row second column వదిలిపెడితే 1 2 1 3 ఉంటాయి. So 1 2 1 3, 1 2 1 3. Look at this. For third row, second element 4. So leave the third row. So 4 lies in second column, leave second column. So third row second column, after leaving this third row second column, we will be left with 1 2 1 3. ఇవి రెండు వదిలిపెడితే 1 2 1 3 మిగులుతాయి. సో 1 2 1 3. అయితే ఈ రెడ్ అండర్ మనం రౌండ్ అప్ చేసిన 1 cofactor, 2 cofactor, 4 cofactor, 3 cofactors. ఈ 4 ఎలిమెంట్స్ కోఫాక్టర్స్ సైన్ చేంజ్ అవుతుంది కాబట్టి మైనస్ తో మల్టిప్లై చేసి 4 ఎలిమెంట్స్ తీసుకోవాలి. సో ఇక్కడ మైనస్ ఆఫ్ 1 into 3 3, 1 into 2 2. minus 3 minus 2, 1 minus 1. Cofactor of the last third row, last element 9, name it as C3. So this 9 lies in third row, third column. So if you remove third row, third column, you will get 1, 1, 2, 2. 1, 1, 2, 2. Third row, third column వదిలిపెడితే మిగిలినవి 1, 1, 2, 2. So 1 into 2, 2. 1 into 2, 2. So 2 minus 2 is 0. So after calculating all cofactors, 9 for 9 elements. 9 elements are there in A. So 9 cofactors. A1, B1, C1, first row. A2, B2, C2, second row. A3, B3, C3, third row. Now let us write the cofactor matrix. Cofactor matrix. Cofactor matrix of A. Let us name it as B. So what are the cofactors? First row, A1, B1, C1. 6 minus 15, 6. 6 minus 15, 6. First row, 6 minus 15, 6. The second row cofactors, minus 5, 8, minus 3. Minus 5, 8, minus 3. Third row cofactors, 1 minus 1, 0. 1 minus 1, 0. So this is the cofactor matrix. Now we have to find adjoint, anubandha matrika. So what is adjoint of A is the transpose of B, that is BT. The transpose of BT is the adjoint matrix of A. And the transpose of the cofactor matrix will be the adjoint. So this is how we find adjoint matrix of a 3 by 3 given matrix. Already manam chesam. So how to find the transpose? Just simply converting rows into columns. So first row becomes first column. 6 minus 15, 6. ఈ రోను కాలంగా కన్వర్ట్ చేయాలి. 6 minus 15, 6. The first row becomes first column. And the second row becomes second column. Rows ను columns గా కన్వర్ట్ చేస్తే దాన్ని ట్రాన్స్పోజ్ అంటాం, వ్యత్యయం. థర్డ్ రో థర్డ్ కాలం అవుతుంది. అక్కడ అడ్డు వరుసను ఇక్కడ నిలువు వరుసలుగా మార్చుతాం. దాన్ని ట్రాన్స్పోజ్ అంటాం, టీ. సో ఒక మాత్రికకు ట్రాన్స్పోజ్ అంటే కన్వర్టింగ్ ద rows into columns. So this is 6 minus 5, 1, minus 15, 8, minus 1, 6 minus 3, 0 is the adjoint matrix. Now we have to calculate the determinant of A. Now det A, what is A? Now I will write again. Now A 1 1 1, 2 2 3, 1 4 9. In Kramer's also we calculate the determinants. Here also we have to calculate the determinant. So now the det A the determinant of A. So let us calculate on first row. So 1 into the remaining 4, 2, 3, 4, 9. And for this, we have to change its sign. That's why I am putting minus. And for 1, the remaining, except 2, 4, the remaining 4, 1, 2, 1, 3, 9. And for the last one, except 3, 9, take the remaining 4, 2, 2, 1, 4. దాని కింద ఉన్న 2 నెంబర్లు వదిలిపెట్టి మిగతా 4 నెంబర్లు రాసుకోవాలి. ఇది మనం డిటర్మినెంట్ చాలా మనం క్రామర్స్ మిగతా వాటిలలో perfect with finding determinant. So this is how we find determinant. 2 into 9, 4 into 3, 2, 9, 3 into 1, 2, 4 ja 8, 2, 1 ja 2. 18 minus 12, 6. 18 minus 3, 15. 8 minus 2, 6. You can take direct by using the definition also you can calculate the determinant if you know the cofactors. Element and its cofactor. Element, its cofactor. Element, its cofactor. The sum of the product of the element and its cofactor is the determinant. So if 6 minus 15, 6 manam cofactors unnai kabatti first row element and first row element cofactor. ఇట్లా మనం డైరెక్ట్ గా కూడా డిటర్మినెంట్ కనుక్కోవచ్చు. టు అవాయిడ్ కన్ఫ్యూజన్ మనం ఇందాక ఎట్లయితే డిటర్మినెంట్ కనుక్కుంటూ ఉన్నామో అదే పద్ధతిలో మళ్ళీ నేను చేస్తున్నాను. మనం కోఫాక్టర్స్ ఉన్నాయి కాబట్టి డైరెక్ట్ కూడా డిటర్మినెంట్ రాయొచ్చు. యూ కెన్ రైట్ డైరెక్ట్ ఎలిమెంట్ అండ్ ఇట్స్ కోఫాక్టర్. 1 into 6, 6. And 1 into minus 15, minus 15. So 1 element then cofactor minus 15. So 1 element then cofactor 6. So by using the definition also you can write determinant directly. So this is 6 plus 6, 12 minus 15, that is minus 3. The determinant is minus 3. Therefore, det A is minus 3. So after finding adjoint and det, that is the inverse. The definition of inverse is adjoint A by det A. So this is the definition of inverse. So A inverse. So 1 by det we write separately. So 1 by minus 3 the determinant and into adjoint matrix. 6 minus 5, 1. Minus 15, 8 minus 1. 6 minus 3, 0. So this is adjoint matrix. By determinant, this denominator we are writing side 1 as 1 by minus 3. So this is the inverse matrix. So this is the procedure to find inverse matrix. Already we learned in previous classes how to find adjoint and how to find determinant and how to find inverse. To find inverse, we have to find adjoint and determinant. So adjoint by determinant is the inverse matrix. So this is all about inverse matrix. So now we have to find the solution. So in this method, what is the solution? We have to find the solution. That is, solution is variable matrix X, Y, Z. The X will be A inverse into D. So this will give the solution. Already we have the inverse, that is 1 by minus 3 into 6 minus 5, 1, 6 minus 5, 1, minus 15, 8 minus 1, 6 minus 3, 0. This is A inverse. Multiply with D. What is D? The constant matrix 163. This is the Sthira Rasi Matrika 163. 163. Now this will give the solution. We know how to multiply the matrix. Rows with columns. Rows with columns. So this is R1, this is R2, this is R3. So this is C1. First matrix rows and second matrix column. That is, you take R1 multiply with C1. Take R2 multiply with C2. Take R3 multiply with C3. So this is the procedure for multiplication, and 1 by minus 3 will be same. So here 1 by minus 3. Take first row and column. 6 into 1. 6 into 1. Minus 5 into 6. Second element into second element. 1 into 3. Third element into third element. This is the row into column multiplication. Similarly, R2 into C2. Second row elements with first column. Minus first number into first. Minus 15 into 1. 8 into 6. And minus 1 into 3. Third row into column. 6 into 1. Minus 3 into 6. 0 into 3. So this is the multiplication. A inverse into D. Now simplify. So this will 1 keep minus 1 by 3 as it is. 6 into 1, 6. 5, 6. 5, 6 jar 30. 1, 3 jar 3. So minus 15 into 1. 8 into 6. Minus 1 into 3. 6 into 1. 3 into 6. 0 into 3 is 0. Further simplifying, 1 by minus 3, keep as it is. 6, 3, 9. 9 minus 30 minus 21. 9 minus 30. 15 minus 3. 48 minus 18. 6 minus 18. 1 by minus 3. 30 minus 9 is 21 and minus 21. 48 minus 18 is 30. And 18 minus 6, 12. That is minus 12. Now, divide all three elements with minus 3. So now x is equal to minus 21 by minus 3, 30 by minus 3, minus 12 by minus 3. So this is the final matrix. So minus minus will get cancelled. This will be 7. This is minus 10. This is 4. So this is x. X is equal to 7 minus 10, 4. So what is x? X is the variable matrix, that is x, y, z. So that is 7 minus 10, 4. So from this, the solution, therefore, the solution is x value 7, y value minus 10, z value 4. So this is the procedure in matrix inversion method. First, calculate inverse and then find the solution. X is equal to A inverse D. A inverse and D, multiplying A inverse D, you will get the required solution, that is x, y, z values. And you can check whether your answer is right or wrong by substituting these values in one of the given equations. Now, let us take up one more problem from the exercise 3. Same. Solve the given equations by matrix inversion method. X minus y plus 3z, x minus y plus 3z is equal to 5. 4x plus 2y minus z is equal to 0. Minus x plus 3y plus z is equal to 5. In first step, convert into matrix equation the coefficients of x, y, z in first 1, minus 1, 3. In second equation, 4, 2, minus 1. Third, minus 1, 3, 1. So this is A. Let us name it as A. And the second matrix, variable matrix, name it as X. And third one, 5, 0, 5. So this is, name it as D. So this is the matrix equation. This is matrix equation A D. Now let us find the cofactors. Cofactors. So in first row, so this is R1, this is R2, this is R3. In first row, CF, the cofactor of first element 1, let us name it as A1. So the first row, first column, take the remaining, eliminating first row, first column, 2 minus 1, 3, 1. 2 minus 1, 3, 1. So 2 into 1, 2. 3 into minus 1, minus 3 into minus plus 3. 2 plus 3, the cofactor is 5. So next, cofactor of the second element, that is minus 1. So for this, we need to multiply with minus for this one, and for this one, for this one. For these 4 elements, we have to change the sign for cofactor. So now multiply with minus. For this first row, minus 1 is in first row, minus 1 is in second column. So removing first row, second column, we get 4 minus 1, minus 1, 1. 4 minus 1, minus 1, 1. 4 minus 1, minus 1, 1. So that is minus into 4 into 1, 4. 1 into 1, 1. So minus 4 minus 1, 3. So minus 3 cofactor of this one. Now the cofactor of 3, that is C1. So for this, first row, third column, eliminating 4, 2, minus 1, 3. 4, 2, minus 1, 3. 4, 3 ja, 12, minus minus plus 2. That is 14. So the cofactors of first row elements 5 minus 3, 14. Now in second row, the cofactor of 4, second row first element. So we have to multiply with minus. You can see second row first element 4. We have to multiply minus. So leaving second row and first column, we get minus 1, 3, 3, 1. Minus 1, 3, 3, 1. Minus 1, 3, 3, 1. minus 1 3 3 1. So minus into minus 1 1 minus 1 3 3 9. So minus 10. So minus into minus, this becomes plus 10. Next, second element, cofactor of second row, second element. So second row, second column, eliminating, we get corner elements 1 3 minus 1 1. 1 3 minus 1 1. ఈ సెకండ్ రో సెకండ్ కాలం వదిలిపెడితే మనకు 1 3 minus 1 1 వస్తుంది. 1 into 1 1 minus 3 minus plus 3. 1 plus 3 is 4. So cofactor of second row third element, that is minus 1 C2 అనుకోండి. సో దీనికి కూడా మైనస్ తో ఇంటూ చేయాలి. We need to multiply with minus. So leaving second row and third column, 1 minus 1 minus 1 3. 1 minus 1 minus 1 3. 1 minus 1 minus 1 3. So minus into 1 into 3, 1 into 1. So 3 minus 1 2. This is minus 2. So now in third row, cofactors of third row, first element, that is minus 1. Let us name it as A3. So this is eliminating third row, first column, minus 1 3 2 minus 1. Minus 1 3 2 minus 1 will be there. Minus 1 plus 1. 3 2 ja 6. 1 minus 6 is minus 5. Cofactor of third row second element 3. Let us name it as B3. So for this we need to multiply with minus. With minus. So don't forget to multiply minus. So eliminating third row second column, 1 4 3 minus 1. 1 4 3 minus 1. 1 4 3 minus 1. So minus into minus 1 4 3 ja 12. Minus 13 into minus, this is plus 13. The last cofactor of last element. So removing third row and third column, 1 minus 1 4 2. 1 minus 1 4 2. 1 minus 1 4 2. So 1 into 2, 4 minus 4 into minus plus 4. 4 plus 2, 6. So all the cofactors. Now write the cofactor matrix. Cofactor matrix of A. Those name it as B. A యొక్క cofactor matrix ను B అనుకుంటే the first row ఏముంది cofactors A1 B1 C1 A2 B2 C2 A3 B3 C3. So ఇది cofactor matrix. Now adjoint అంటే ఈ cofactor matrix ట్రాన్స్పోజ్ అంటే ఇందులో అడ్డు వరుసలు నిలువు వరుసలుగా మారుతాయి. సో A1 B1 C1 అనేది ఇక్కడ రో కాలం అయిపోతుంది. అదేవిధంగా సెకండ్ రో సెకండ్ కాలం, changing rows into column. So that is transpose. What is transpose? Interchanging the rows and columns, that is the transpose. So this will give us the adjoint matrix. First row, first column ga rayali A1 B1 C1. So in first row, what are the cofactors? A1 B1 C1 5 minus 3 14. So ikkada column ga rastam 5 minus 3 14. 5 minus 3 14. The second row cofactors 10 4 minus 2. These 10 4 minus 2. Second cofactors ఇవి 10 4 minus 2. ఇక్కడ సెకండ్ కాలమ్ గా రాస్తాం 10 4 minus 2. And third row cofactors minus 5 13 6. Minus 5 13 6. So this is the adjoint of A. So this is how to find adjoint matrix of a given 3 by 3 matrix. Now we have to find the determinant. Now let us find the determinant by using the definition. So what is the determinant? Element with their cofactor. Element B1 and capital B1 its cofactor. Small c1 element and capital C1 its cofactor. So in previous problem, we calculated the determinant in normal method, but already we have cofactors. I told you we can find the determinant by using the definition. So what is the A1 element of the matrix? So 1, first row elements 1 minus 1 3. Let us take first row elements 1 and its cofactor is 5. So 1 into 5. 1 into 5. Second element minus 1 and its cofactor is minus 3. And third element is 3 and its cofactor is 14. 3 cofactor 14. You see 1 cofactor is 5. 1 into 5 minus 1 into minus 3. 3 into 14. 3 into 14. The first row elements and their cofactors. So the sum of the product of the elements with their cofactors is the determinant. So 1 into 5 minus minus becomes plus. So 14 3 ja 42. 42 plus 3. 45 plus 5 50. So the determinant is 50. So you can find determinant in both ways. If you know the cofactors, you can find in this way. Otherwise, you have to find in normal procedure. element and taking the 4. That is itself finding the cofactors. So now write the inverse. What is inverse? Inverse, A inverse is adjoint matrix by its determinant. This is the inverse. So now A inverse is equal to determinant I am writing as 1 by and adjoint matrix as it is 5, 10 minus 5, 5, 10 minus 5, minus 3, 4, 13, 14 minus 2, 6. So this is adjoint 14 minus 2, 6. So adjoint by det. By det we can write 1 by 50. So this is inverse matrix. So after finding inverse, now we have to calculate the solution. So that is x is equal to A inverse D. This is the solution. Now we have to multiply A inverse with D to get the solution. A inverse 1 by 50 and 5, 10 minus 5, minus 3, 4, 13, 14 minus 2, 6. So this is A inverse into D. What is D? Constant matrix 5, 0, 5. So this is 5, 0, 5 D. In first step, converting it in matrix form, the constant matrix 5, 0, 5. This is D. So after finding A inverse, multiply the inverse with the constant matrix D. The multiplication, we multiply the rows of first matrix with the columns of second matrix. So this is first row, second row, third row. There are 3 rows in first matrix and 1 column in second matrix. So the multiplication will be R1 C1, R2 C1, R3 C1. So this is the method of multiplication. So after multiplying, we get, so keep 1 by 50 as it is. You need not multiply. You need not multiply 1 by 50 inside. Now R1 C1, first row elements with first column. First element, 5 into 5, 5 into 5. Second element into second, that is plus 10 into 0. Third element into third, minus 5 into 5. So this is first row multiplication. And second row multiplication, minus 3 into 5, 4 into 0, 13 into 5. And third row, multiply with third row, 14 into 5, minus 2 into 0, 6 into 5, 6 into 5. So very simple, only 1 column is there. So this is multiplying the 3 rows with the column, first column. Simplify. Keep 1 by 50 as it is up to the last step. 5 5 ja 25. 10 into 0 0. 5 5 ja minus 25. Minus 3 5 ja minus 15. This is 0. 13 5 ja 65. 14 5 ja 70. 0. 6 5 ja 30. So next, keep 1 by 50 as it is. 25 minus 25 will be 0. 65 minus 15, 50. 70 plus 30, 100. So now divide all three elements by 50. 1 by 50 you bring inside. So the 50 divides all the three elements. So 0 by 50, 50 by 50, 100 by 50. So 0 by 50, 0. 50 by 50 is 1. 100 by 50 is 2. So this is x, and x is nothing but xyz. Therefore, the solution is x value 0, y value 1, z value 2. The solution for this sadhana, x value 0 and y is 1, z is 2. So this is matrix inversion method. The name itself is very clear. It involves the inverse matrix. First, we have to calculate the inverse matrix. That is by calculating adjoint and determinant, and then multiplying with the constant matrix, so that x is equal to inverse d. That will be the solution. ఇక్కడ విలోమ మాత్రిక కనుక్కోవడం ముఖ్యం. విలోమ మాత్రిక into, so here determinant and adjoint, you have to find the determinant and adjoint, then inverse and multiply. So in this method, you should be perfect with finding adjoint matrix and finding determinant and then inverse and then the product multiplication. So this is also simple. In Cramer's, only you need to find the determinants, then you will get the solution. Here you need to find adjoint matrix and determinant, then inverse, then product A inverse into D, then you will get the solution. So practice some more problems. So in the next class also we will continue this method. So as this solutions, finding solutions is very important. So I will continue to solve some more problems in the next class. So you can also practice some problems from the text and also from the solved problems. Okay, thank you. Thank you for watching this.